So you have a maths test coming up, and in preparation for this, over the last few weeks, you have been effortlessly encoding all the information pertaining to formulas, theorems, concepts, etc. What is the one cognitive faculty that will allow you to use this encoded information on the day of the test? It is the faculty of memory storage. Hello and welcome everybody to third video in the memory series wherein we learn about the concept of memory storage. You can find all the listed videos that cover this particular topic in the series in the description below as well as in the comment section. We will cover two videos in the series. The first video, we will give an introduction on the topic and define what is memory, as well as look an overview of the three key stages that include the stage of memory formation. In the second video, we cover the information pertaining to the first stage of memory information, which is encoding. We highly recommend that you watch two videos before you proceed with the current one, in order to pursue the study of memory in a logical manner. You find the link of these videos in the description below as well as in the comment section, or by clicking the I button on the top on the right corner of the screen. However, if you already know these topics and are well versed with the definition of what is memory and know the concept of encoding well as different types of encoding, then feel free to pursue with the current video. And that being said, let's move on. We will cover in today's video, we start this video by defining the concept of memory storage, and we will move to learn the postulated Atkinson and Shiffrin multi-storage model of memory storage. In that, we cover the different storage stages of the Atkinson storage model, which include the sensory memory, the short, the memory, and the long-term memory. We then move on to look for the evidence for multi-storage model, and finally end the video by critically evaluating the multi-storage model. With that being said, let's proceed to the video. As we are learning in the previous videos in the series, memory formation include three different stages. Storage is the second stage. Is this process? Let's start by asking the question, what is memory storage? Memory storage can be visualized as the storage space such as this box, which can be seen is overlaid on the schematic of the brain, which stores the information that has been encoded and uploads the same in the storage space. More formally, we can define memory storage as the act and the process of storing effortless encoded information in the brain with an aim to create a more permanent record of it for retrieving it or recalling it at a later stage. Now we have the understanding of what memory storage is and know the definition. Let's understand the stage of memory storage with the postulative Atkinson and Shifrin's multi-storage model. Richard Atkinson and Richard Shiffrin proposed the purpose of the cognitive ability of memory storage as feature viewed in the definition to store previously encoded information in order to supply us with this information at a later stage in the future. In 1968, they proposed a structural model, or the model of memory storage referred to as multi-store model of memory storage, with an aim to explain how effortful encoded information is stored in human memory for serving the very purpose of providing it at a later time. The multi-store model was proposed in the 1960s, an era in cognitive psychology wherein cognitive cycle adjusts explaining human cognition by drawing parallels between the functionality of computer and human brain. In light of the influence of this approach during Sarah Atkinson's and Shiffrin also drew parallels between the information processing and memory storage occurring in computers with the information processing and memory storage occurring in human brains, and posted that effortful encoded information passes through various distinct stages and is subject to specific control processes before being fully consolidated in the memory storage facility, retrieval, or recall. Specifically, Atkinson and Shiffrin model propose that the encoded information passes through 3 distinct stages and 3 different types of control processes. In this process, the 3 distinct stages, that is the model proposed, and sensory memory, short-term memory, and finally the long-term memory. Moving on, let's dive deeper into this model and understand how the encoded information passes through 3 distinct stages of memory storage and how it is augmented by the control process. With the help of a bulk scenario stands the multi-store model schematic. So according to the modern schematic and this model, the process of memory storage begins when we first come across information from outer environmental stimuli and we perceive and encode this information via the sensory routes. This recent perceived and encoded information then directly reaches the first stage of the multi-store model, which is the sensory memory stage. Now, before proceeding to understand what each of these units are, note that the multi-store modeling proposes a number of control processes. Now, control processes are a set of intermediate cognitive processes that govern and facilitate how successfully the information is transferred from one unit of the model to another. In this model schematic, we highlight how the control processes is yellow in order to help you distinguish it from the memory units themselves. Moving on, according to this model, it is crucial to be active attention to the information in the sensory memory for registering it, to proceed to the storage unit, which is the short-term memory. In this information storage stage, the cognitive process of attention is the control process existed. It is the first control process introduced in the multi-storage model, and its chief function is to facilitate the transfer of encoded information from the sensory stage to the SDM or short-term memory. Noted that any encoded information at the sensory memory stage that is not subjected to active attention is often lost and is not therefore transferred to the next stage of the short-term memory. Following this, the model proceeds to the next storage unit, which is the short-term memory or the SDN stage, which is the capacity for the SDM is low, due to which the information in this stage is only held for a short period of time. This characteristic where this unit gets its name from. Now, because of the short-term memory nature of this memory storage, it is key that this information is SDM is subject to the next control process, which is active rehearsal. Now, the active rehearsal allows the information in the short-term memory to be active and maintains it there. There are various ways in which rehearsal might occur. One common example is the repetition of information verbally, such as when you are trying to remember, see a 4-digit chord by repeating it constantly, verbally, till you get that piece of information written down on paper or consolidated. This brings us to the next function of the control process of rehearsal, which is to maintain the information in the system long enough so that it can be transferred into the long-term memory storage unit. Now, the continuous process of maintaining the incoming encoded information from the sensory unit to the system and holding it long enough in the system to transfer it to the long-term memory is subject to the rehearsal loop process, which is simply going back and forth with the control process of rehearsal in order to transfer the information from one stage to another. Now, the final control process in this model is retrieval. Retrieval is essential in the cognitive process, which allows to bring back the information from the long-term memory to the short-term memory, and as and when we want to use it. Now, note that retrieval is a separate stage in the stage of memory formation, and that we will cover the topic in great detail in an upcoming video. But for now, we know that retrieval is the control process in the multi-store model, where it is allowed that the retrieval or recall of information from the long-term memory to the short-term memory as and when we require it. Alright, so let's look at that interim summary of the model so far. So according to the Atkinson-Shiffrin model, information passes via 3 stages, which include the sensory memory stage, the short-term memory stage or SD, the long-term memory stage or LTM. They are all separate locations in which the information is stored as per the model. The schematic information transferred from one stage to the other stage occurs in a linear and sequential process. In this model, SD serves as the gateway which the information can access the LTM, and various memory stores operation in conjunction with the permanent LDM stores via the process of attention, rehearsal and retrieval. Now let's move on to the next section, wherein we will briefly look at each of the 3 stages. Now note that deep diving into each of the units of the sensory memory, ASTM and LTM, is beyond the scope of the current video, because dedicated videos on each of the topics will be released in the upcoming videos. Now let's build on a working understanding of each of these units as per the preparation of the upcoming videos. The first stage is the sensory input stage, to refer to us as sensory memory. The sensory memory refers to a briefly memory storage unit in which the incoming information that enters our cognition via the sensory portal, for example, vision, is momentarily stored until it passes to the next storage space, which according to Atkinson and Shiffrin model would be the short-term memory storage space. Let's look at example to understand sensory memory better. Imagine you're crossing a road, and for that you look at the traffic lights at the time. In doing so, you do briefly register the color of the traffic light in order to discern the appropriate action of either crossing the road or not, which you can recall already from the stored information from the past in the LTM. Now the capacity of this particular unit is accounting all the sensory experiences and the duration of the amount of time the information is retained in this unit is very small, ranging from 1 foot to half a second. This is because of this short duration that is being undivided attention paid to the information at this stage. It is crucial for it to pass to the next stage. Finally, the encoded information in this unit of memory is since specifically moving from the next stage refers to as short-term memory storage, or SD for short. Now this team has referred to as short-term temporary storage unit, which receives its input either from the sensory memory or from the LTM via retrieval. The STEAM acts as a gateway for retrieving information from the LTM as well. In terms of capacity, the STEAM can hold up to plus 7 items, which is ranging from 9 to 5 items. Holding 7 items is the average capacity of our STEAM. Now hold these plus or minus 7 items for approximately 20 seconds, which is much longer duration compared to our sensory memory. And the encoding in the STEAM is usually auditory in nature. Recall from previous video on encoding, there are 6 types of memory encoding, and auditory encoding is one of them. An example of DM would be trying to remember and store information for your friend's phone number. Now 20 seconds of this duration is a long enough time for you to repeatedly rehearse this information in order to transfer this information to the next and final memory storage stage, which is LTM or long-term memory. Now the LTM has been referred to as a more permanent storage unit in which the incoming information from the SDM is stored and consolidated in a permanent storage from which it can be retrieved or recalled as and when you need it in the future. Unlike the STEAM, the LTM is a continuous information storage system and has unlimited capacity as well. Encoding in the LTM is mainly schematic in nature, but auditory and visual encoding is also undertaken. An example of LTM can be included during an exam when you recall and retrieve the information on the desk and material from your LTM. Alright? So, it was a brief review of each of the units of the multi-storage model. Now let's move on to look at some evidence that suppose the existence of these distinct storage units. The evidence for the existence of distinct stores of memory comes from studies that the patients have suffered from brain damage. These studies have shown that patients with bilateral damage to the hippocampus region had nearly no ability to form new long-term memories, but that esteemed capacities remained intact. Famous case as such as of Henry Molaison, famously known as HM, who underwent several bilateral medial temporary lobectomy, which led to the removal of the hippocampus region, which was a good example of this, wherein the esteemed capacity remained intact, while some specific types of LTMs were damaged. Furthermore, evidence from experimental studies undertaken with healthy participants with intact cognition had supported the existence of distinct memory stores. For example, a study in Glasner and Knudts, undertaken in 1966, showed that when participants are presented with a list of awards, they tend to remember the first few and last few words more when compared to that of the middle list. These results supported the existence of a separate LTM and esteemed stores. The explanation being that the words early in the list were put in the LTM because the participants had time to undertake rehearsal for transfer of information to the LTM, while the rewards in the end went to this esteem as they had time to simultaneously and active rehearse for maintenance in the STEAM. Let's now move on to the last part of the video, where we critically analyze and evaluate the multi-store model for look for strengths and weaknesses. Now, although previously the idea of different memory stores has been proposed by psychological judges such as William James, who had not developed further, we are brought into the fruition that the Atkinson-Shiffrin model in the 1960s, all the evidence in supporting the Atkinson-Shiffrin model did find fundamental differences between the propositions of memory stores by William James and Atkinson and Shiffrin. Furthermore, in relation to the previous trend, we can state that this was the first structural model that clearly described each memory stage and had been instrumental to drive further research within each type of memory storage unit, which over the years has also allowed to refine the current model as well. Finally, this model has been supported by evidence from both experimental studies with healthy population as well as from clinical brain damage population, wherein the existence of different memory stores has been found. In terms of the weaknesses, the model has referred to as oversimplified, linear, passive, one way, and has failed to capture the complexity of information passage during the process of memory storage. Specifically, the model suggested pertaining to the existence from both long and short-term memory operating as two single units in a uniform fashion that has been called out as a weakness. Since now we have evidence this is not the case. Furthermore, the early criticisms of the model pertaining the tripart format of the model, it is specifically target at the inclusion of sensory unit as a separate parsimous. Only speaking, the sensory memory acts as a control process like rehearsal, attention, retrieval, acting as a sensory register instead of distinct structure as proposed to the original model. Later revisions of this model addressed this claim and incorporated the sensory register within the short-term store. Instead of including sensory memory as a separate unit altogether. Additionally, it has now become apparent that both short and long-term memory are way more complicated than it was previously perceived and explained by this model. Short-term memory, for example, is more than just a unitary store. The working memory model proposed by Baddeley and Hitch in 1974 proved this by showing that short-term memory is more than just one simple unit store comprising of different components. For example, central executive, visuospatial, sketchpad, auditory loop, etc. In this case, long-term memory, it is unlikely that different kinds of knowledge such as remembering how to play a computer game, rule of subtraction and addition, and remembering what we did yesterday are all stored within a single long-term memory store. Indeed, different types of long-term memory have been identified, such as episodic memory, procedural memory, semantic memory, etc. All the topics that we cover in the further videos of the series. Furthermore, the model has been criticized as suggesting rehearsal as the key store controlled process which facilitates transfer of the information into the LTM. There is little evidence supporting this hypothesis, and the long-term recall can in fact be better predicted by other frameworks, in which the items which are encoded at more deeper semantic levels and are shown to have stronger traces in the long-term memory. That is, the information is subjected to an elaborate process having a better chance of entering the long-term memory as opposed to that subject to shallow or simplistic rehearsal process as suggested by this model. Alright, so we come to the end of this video on memory storage and the multi-store model proposed by Atkinson and Shiffrin. Thank you for watching. Thank you for your attention. If you found value in this video, I want you to follow the entire memory series as well as the upcoming videos on cognitive psychology, neuroscience psychology. In general, the research method used in this field. Please make sure to subscribe to our channel and also like this video. Send us the comment and share this video with someone whom you think will benefit, and don't forget to press the bell icon as it will help you stay updated.